Hi, I'm Keenan Casey with TouchPlus.com. In this lesson, we're going to be looking at TCP, specifically how TCP connections work. As you know, TCP is a reliable, connection-ful protocol that provides a lot of safety and performance. In this lesson, we're going to be looking at the connection-ful aspect of TCP. It's a stream-based protocol. It provides the abstraction of a stream of bytes that go in both directions. In order to do so, it has a setup and teardown process. We can think about TCP creating a data pipe between the client and the server. The client in this case is the connection initiator, and the server is the host that's contacted by the client and responds. Let's begin by looking at how TCP connections are set up. This involves a process known as a three-way handshake. First, the client sends a TCP SYN packet to the server. This specifies the initial sequence number. It doesn't include any data. In response, the server will send back a FIN and ACK packet. The server allocates buffers. It specifies in this packet the server's initial sequence number. Thirdly, the client will respond with an acknowledgement packet, an ACK. This may contain data, and this begins the connection transfer. This is the creation of the data pipe. At the end of a TCP connection, the connection has to be torn down. This can happen in a couple different ways depending on if the client or the server wants to close the connection. In this scenario, the client will be closing the connection. The client will send a FIN packet. This is a control segment, doesn't have data. It's a special "I'm done with this connection" packet. The server will respond with an ACK packet. It will next send a FIN packet, which will cause the client to go into a timed wait. After this time wait period, the client will close the connection. During this time period, the client should send back an ACK. This last ACK packet will inform the server that the client has closed the connection, and the server will also close the connection. The question we've considered in this lesson is, how does TCP provide the abstraction of a byte stream, the abstraction of a connection? In order to do so, it has to maintain state at both ends. It has to set up that state. It has to tear down that state. So there are processes for the setup and teardown, the connection creation, the connection destruction for both ends. What this translates into is overhead. Overhead in terms of communication, in terms of processing, in terms of memory, and in terms of time. So this abstraction of a connection between client and server requires a lot of cost. It requires a lot of investment in terms of packages that are exchanged, in terms of memory that has to be stored on both sides, and in terms of time. In this lesson, we've been looking at TCP's connection-oriented mechanisms. It's connection setup and connection teardown. We've been in the transport layer of the Internet protocol stack. I'm Keenan Casey for TouchPlus.com. Thank you for watching.